let's label the coordinates together. So you've got the first one up here, which is 0, 3. And then the third bullet point says it's a vertical height 27 when distance is 120. So it's just a random point over here. And we don't know, this is why this question is harder than the other ones. We don't know the last question. And what do we know about this point here?
It's like halfway.
Halfway, but we also don't know what halfway is. But we know the y. What's the y? No, actually, no, we know the... Oh, wait. Oh, no, yeah, it's fine. What's the coordinate? We know it's 90 something, isn't it?
Yeah.
But we don't know what y is, so we just have to say y. Make sense?
Yeah.
Cool. Oh, actually, I'm just going to put k here just to avoid any. It's just another unknown. Does that make sense?
Yeah.
Cool. So this one's much, much, much harder because we don't know the factors, right?
Mm,
We don't know
no.
the factors because we don't know when it crosses over here, do we?
Yeah.
And we don't know this point. Agreed?
Yeah.
Do we know the turning point fully?
No.
No. So we can't use any of the methods we talked about. But I love these questions because they're really good revision for all the quadratic stuff, but also something else now. So now we're after this, we're definitely done with quadratic. So it's a final way of doing it. The big way is y equals ax squared plus bx plus c. That's the first way you learn for any quadratic, isn't it?
Yeah.
Cool. What's the y-intercept? What's the plus c?
3.
Cool. So the long way to work that is kind of obvious, but the long way to work it out is just sub 0, 3, and you would have got that because you get 3 equals a times 0 plus b times 0 plus c. Therefore, c has to equal 3. So we can narrow the equation down. We've got one part of the puzzle. It's just a puzzle with 3 different unknowns. So y equals ax squared plus bx plus 3. What other coordinate do we know? We've already used the 0, 3.
90.
The full coordinate that we know.
Oh, 120 and 27.
Yeah. Let's just sub that in, right?
Mm.
So sub 120, 27. What do we get? We get 27 equals a make sense?
Yeah.
Cool. So 120 squared times a plus 120 times b plus 3. We can just tidy the equation up. So we get 14 400a plus 120b equals 24.
Mm-hmm.
We can divide everything by 24. Actually, no, we can't. We can divide everything by 12 if we want to. So we get 1200 a plus 10b equals 2. Oh wait, we could have divided by 24, my bad. 600a plus 5b equals 1. Yeah?
Yeah.
Well, how many unknowns do we have? We have 2 unknowns, right?
Yeah.
So we have to do simultaneous equations. This was the bit that you probably could have got somewhere here if you knew the method, but the next bit you probably wouldn't have known unless we've gone through it before. So apart from completing the square, what else in maths can you associate with turning points? Which other topic? I hinted at it before.
Simultaneous equations.
Oh no, but specifically for turning points, what other topic has turning points in them? Stationary points.
Uh,
So the other topic with stationary points is differentiation, isn't it?
Differentiation. Oh, yeah.
Yeah?
Yeah.
Cool. So this is our equation of our curve. What do we get when we differentiate it? What's dy by dx?
Would it be? Would you?
Obviously, it will be in terms of a and b, but you just have to differentiate with respect to x. So what do you get when you
Would you?
differentiate x
Wait.
squared?
Would it be two? Would it be two ax?
Yeah, exactly, 2ax. And what do you get when you differentiate bx?
Would it just be bx?
What do you get when you
Or would it just be
differentiate?
b?
Yeah, because if you differentiated 10x, it would be 10. So if you differentiate bx, it would just be b.
Yeah.
What does dy by dx equal at the turning point?
90. Okay.
What's the gradient? Oh yeah, x is 90, but what's the actual gradient? At every turning point. Do you see my line there?
Yeah.
It's flat, right? So what's the gradient?
0.
Yep. So when x equals 90, the gradient equals 0. Basically, dy by dx must be 0. So 180a plus b equals 0. This will form our second equation. What do you think we do next? The rest is very straightforward. Equation 1, equation 2. Just solve them simultaneously.
Okay.
Okay?
Yeah.
Cool. So
Wait, but like with questions, how would you know if you should integrate or differentiate?
We'll go through many examples and you'll get better over time. But in this case, because it was a turning point question or a maximum point question, it's expected that you know that turning points, they only show up twice in the spec. One with completing the square, but this wouldn't work here because there's too many, it's just too confusing. And the other topic turning points show up in is differentiation. So it's expected you try completing the square or differentiation in this question.
Yeah.
Integration, that it would be a question, it has a clue about the area. Cool. So that's what I got when I solved the simultaneous equations. I took equation 2, I times it by 5, but you can do it however you want. I got my a and b and I just put it back in the original form that we said we would use.
Yeah. Okay.
Just to summarize, okay, I'll give you practice questions, but there's 3 different forms: the completed the square form, the factorized form, and the full form. This method actually always works, but then you have to use simultaneous equations, so it's just way longer. But it was the only method. Completing the square is also a bit longer, but in the other question, it was the only method that worked. The factorizing method is the easiest, but doesn't always work as well.
Okay.